Greetings, Artie from Artifact Electronics. This is part 2 of our Moog Sonic 6 restoration or repair. If you haven't watched part 1, I highly recommend you do so before watching this. Otherwise, you'd be out of sync. And you can easily find previous videos. Why don't I just put a link in the description? Because sometimes I get lazy and it's really not that hard to click on the Artifact Electronics name and then on the videos tab, and that'll show you where video part 1 is. But anyway, we got this thing, we got the lower portion fixed, the power supply, the keyboard. One thing I forgot to mention was I was surprised that all the keys worked properly on this without me having done anything. And as part of replacing the caps in the power supply, I had to lift out the metal tray holding the keyboard and everything else. And there was basically a bunch of pools of contact cleaner on the bottom of the case. So there's the answer to why all the keys worked. Somebody bathed it in contact cleaner and never bothered to clean it up, which of course I cleaned up, but there was a lot of it. I was even thinking of starting to recycle it. But anyway, the one thing I don't think we looked at this last time is here is what was inside. And I guess what it says is that it was assembled on August the 9th, 1974. It was inspected August blah blah 1974, and it was tested on October 10th, 74. Serial number 1797, and the only significance to that is that the original releases or serial numbers lower than, I think, somewhere around 1300, since this wasn't designed at Moog, actually didn't use the ladder filter, but the diode filter, which was lifted out of the ARP instruments. But then later on, since Moog took this over, they redesigned the board and put the ladder filter in there. Of course, people you talk to, anybody who has a serial number with the diode filter claims that those sound best, and the ones that have the ones with the ladder filter claim that those sound best. It's up to you. I don't think there's a huge difference in sound, but then again, I haven't spent a whole lot of time with the diode filter version, and I don't know, this one sounds, the filter sounds pretty good. It's the characteristic Moog sound. So let's see, what else? So now what we get to is doing adjustments. That's why I laid down the panel on some bubble wrap, because we do need access to the keyboard to do the oscillator tunings. And I mean, the instructions are pretty straightforward. But yeah, let's get started on this and see how far we'll get. So for this, we're just going to follow the instructions. I think I showed you last time. I have an original copy of the manual that has the step-by-step adjustments to perform and fold-out schematics and all of that good stuff in there. And I mean, it's not in nice logical order. You know, as you can see, things like point B, the minus 15 volt supply, you know, connect your digital voltmeter, measure the 15 volts, the minus 15 volts, and adjust the pot. So, and the only thing to look out for is you need to do these in order, because if you do them out of order, you may do something that defeats another tuning you've done previously. I mean, these people designed it so they know what order you should do things in. So don't sit there trying to adjust the concert A440 setting and then adjust oscillator A, because you're going to hit the 440 Hertz reference off. So, but for grins, I mean, let's get started. Let's see how bad off we are. And actually, the very first thing is to check the 15 volt supply. the regulated one. Remember, we were missing the entire positive voltage rail, which rendered this instrument useless. And what we're going to do is measure the voltage on the connector over here, and it tells us that the 15 volts is on pin A4 on this board, and well, and the adjustment pot is right here. It's on the other side of the board, but we can access it because there's a convenient hole cut into it. So if we look at it closely, where is A4? A4 is right here. And what do we have? Nothing, because the synth isn't turned on. So, are we... Yep, it's on. So back to A4 again. Well, can't get a whole lot closer than that. And you know what? I'm not going to touch it because it's an old pot. It still works perfectly fine. I guess I could go in and lubricate it and reset it all, but with the new power supply caps I put in, I guess everything's right on track again, and the old voltage regulation is maintained. So no, I'm not going to fight over 0.01 volts on the plus 15 volt rail. The minus 15 volt rail is the same thing, except it's pin A5, and that is, let's make sure we don't short anything, it's minus 14.98, so we're off by 0.02 volts. Again, I'm not going to touch it because that's more than good enough for this. Now, I thought about this, whether I should bore you all with all of the other adjustments, but I'm not going to. Essentially what they consist of is you play low notes and high notes, and then put a frequency counter on it, or I actually prefer to use a guitar tuner on this. You adjust one of the oscillators so the offset and the scaling matches the keyboard perfectly, and then you tune the oscillator A against oscillator B and make sure that there's no beating, no frequency beating there, and that's kind of how you do it. You don't need any special equipment. You do need something to measure the frequency, and whatever you prefer, whether it's a frequency counter or a guitar tuner or anything like that, or if you have, or of course if you have perfect pitch, use your ears by all means. So I'm going to do that off camera, but if something interesting turns up, I'll tune you back in. So as predicted, nothing special happened here. It's with the new caps, things are back to where it was when I was operating nicely, so there were very few adjustments necessary. I did have to tune both oscillators in the absolute and relative adjustments, but everything else was, if it was close enough, I didn't have to touch it. So I did, while things were open, it is a good time to go ahead and lube the pots, or clean the pots, and since they're on the back of the board, you can see, like, over, let's see, I'm pointing at the wrong one, but like if you look at here, it's very easy to get your the oxid in there, give it a bit of a squirt, and then work the controls back and forth. None of the controls really had a problem, except, which one was that? Except in the contour generator, the attack setting, it almost acted like it would work fine, but then it acted like the pod had opened up and you would get really long attacks, and you could usually fix that by giving the knob a couple of turns, but that was the only pot that showed some problems. I mean, everything got sprayed, and I think we are good there. Another interesting thing to point out is how these boards are held into place. Of course, they're held into place by the pot knobs on the other side that's holding these things in securely. But let's see if we can get a little bit closer here and look at some of these. Of course, it doesn't want to focus for me now. Come on. Oh, it's focusing on the back. What if I do this? Okay, there you go. You see these black pins sticking out. And the way those work is they got these really neat pressure fit connectors or hold downs. You press them together and you slide them down and then you let go. And it basically holds them in place with this. And they're all around, there's several of them used to hold both boards in place. And I think I'm at a point now where I'm going to put all of those in. I had taken them out in anticipation of having to remove the boards and replace parts or whatever, but that hasn't become necessary. So we're going to re-secure the boards to the back and put the panel into its rightful place. So let's see. Another thing that's really important, and this was something that I didn't know when I had my first Sonic 6, was that there are two screws. Oh man, we are in focus hell today. There are two screws on the big connector here that hold it into place. And the last one I had, these screws weren't there, and I didn't even know that they existed. And when I sold my last one, of course, I got an emergency call from the buyer 2 seconds after he received it, and he said, it's not working, it's not doing anything. So I'm getting ready to try to troubleshoot what may have happened, and about 3 minutes later I get another email from him saying, oh, this big connector had popped out in transit, and when I plugged it back in, everything was okay. So make sure that these two screws are present and screwed in if you get one of these, because otherwise this is kind of a heavy connector, and if it gets banged around by a common carrier, the chances of it coming out partway or entirely are pretty high. Even though one thing on this one is that there's this piece of foam right behind it that I think is there to prevent it from coming out. And again, thinking back, I think my other one didn't have this piece of foam in there either, so that made perfect sense. Everything was set up just perfectly for that thing to pop out. All right, let's slide the panel back, put all the clamps back on. All the little black clamps that, you know, can't even see that. If you look closely, you will see that there are several. Well, here's one, and here's another one, and they're all over the place. I put the clamps back and put the back panel in and see where we go next. But another thing I wanted to point out is I like to keep the instrument as original as possible, but the speaker just doesn't cut it. I don't have anything to replace it with, but I'm going to see if I can find a full range single speaker to swap this out and at least get a little better sounding synth. Because, yeah, original is nice, but when it comes to the sound quality, I am willing to sacrifice originality for better sound. Alright, so the panel's back in place, and I'm already beginning to think about what other cosmetics do I need to work with here. And the one obvious thing that sprang out was the slider caps, such as this one. There were only two undamaged ones on here, and one cracked into pieces that I found inside the instrument. So what I did was I went through my stash of slider caps, and this is the best I could come up with. Plain black sliders that don't really look anything like the originals, but it's better than nothing. And until I find someone selling the originals, I refitted the instrument with those caps, the slider caps that is. So for whatever it's worth, makes it look a little bit neater instead of having the white slider sticks, you know, in the middle and making it look not too good. But let's go through some of the functions real quick and see if it really does what it's supposed to do. Now, one thing I did was I was going to run this through the quadriverb, which you can see in a previous episode, to get some reverb out of it and then run it through the Roland keyboard amp. But I said no, let's just do the demo or the tryout with the built-in crappy speaker, because after all, that's how it came originally. And I haven't replaced the speaker yet. It's that same speaker I showed you in one of the previous scenes. So that's the way we're going to hear this. So starting from the beginning, I got it set up for now for a very simple setup. Essentially, it has two voltage controlled oscillators, but I've set the balance to oscillator A, enabled the oscillator on the source mixer, pretty much opened up the filter and turned off the resonance, and set the contours or the envelope to give you an organ-like response, which means when you press a key it sounds, when you let go of the key the sound goes away. It doesn't decay or sustain or anything like that. Now we are set to a sawtooth here, and this is what it sounds like. Nothing special. Single oscillator sounds kind of boring. We can change the waveforms that the oscillator produces. It's a sawtooth now. We can go to a triangle, which is the closest you'll come to a sine wave. I mean, you can modify the I guess I spoke too early about the contacts being clean, but adding a filter in, you can further smooth the triangle and make it into much closer to a sine. And then we also have square wave, and we can adjust the duty cycle. I think what this means, it's at 25%, 50%, and 75. So that's the single oscillator. Now what we can do is dial in the second oscillator, which will set up equally to its brother, and we'll turn the balance to A equals B. So we're going to hear both oscillators at the same volume. Well, they're obviously out of tune. You can adjust the pitch of oscillator B to match that of oscillator A, and they're basically playing in unison, even though you will still hear a slight beating because they're running at slightly different frequencies. Now, what gives the synthesizer a fat sound is detuning the oscillators slightly against each other. So So that's basically what the oscillators sound like without any help from any of the other effects. Now we can modulate the oscillators, and for that let's go back and no, let's leave both oscillators on. This is the this instrument has two LFOs, or low frequency oscillators, which can be used to modify several things on here. But for now, let's modulate the pitch of the first oscillator. And for that, let's just select the first oscillator. Turn the balance over to A all the way. And turn the pitch control input, which says XY, over here. And XY refers to LFO-X and LFO-Y. And we have a balance control for the LFOs also. So if we turn that all the way to X, we will only get a single LFO affecting the pitch of oscillator A. Let's use a triangle waveform and see how that affects the sound. Now that's a single LFO affecting that oscillator. Now what we can do is mix the two oscillators, the LFOs, together and cause all sorts of interesting pitch modulation here. Of course, the waveform of the oscillator determines how the pitch is affected. You can see that with a triangle it just goes up and down. With a square wave it'll also go up and down, but there should be no in between. We can then go to a sawtooth, a downward going sawtooth. Or an upgoing sawtooth. And that's just an example of how to modulate the pitch on any of the oscillators. Now we got the balance set to A equals B, so what we're going to do now is make both oscillators audible. One of them is modulated by LFO-X and the other one comes out straight. So and now we can start modulating oscillator B. So that basically alters the depth of modulation on each respective oscillator. So you can play lots of cool tricks with that. Next we'll give it an envelope, the sound, and that is basically altering the voltage controlled amplifier. And what that does is, remember, this kind of sounds like an organ right now. Let me turn off the modulation for now. Key down, it plays. Key up, it stops. Now we can give it an attack, which means the volume will increase gradually. But it disappears the minute you let go of the key. In order to do that, we give it a little bit of decay. And we can see the sound disappear. Now you can bypass that over here and essentially just have a, I don't know if you can see that, but it's basically, it goes up and down. Whereas in this setting, it'll go up to a maximum volume and stay at maximum volume as long as you're holding a key and then let go. But in this case, it doesn't care how long you hold the key, it'll go through its cycle. And if we make things shorter, and then we can take out the attack and give it a short decay, and we get a percussive type of sound. Of course, percussive, we need noise, right? So we go back to the mixer and we dial in some pink noise. And if we take out the sound source, that's what it sounds like. Next, let's add the filter, which is really what the Moog synthesizers were famous for. And just playing a note. First we play with the cutoff frequency. Wait, let me turn off all keyboard control. And then there's the resonance. The high-pitched noise you're hearing is actually the filter self-oscillating. But again, it's not very exciting because the filter stays constant. It's not being affected by what you're playing on the keyboard or where you're at. It just is set to a constant setting. So things will get a little bit more interesting if we dial in the contour or the envelope. Unfortunately, this only has a single envelope generator, so whatever envelope you set for the sound is going to equally affect the filter envelope. The only difference you have is you can dial in the depth of how much the envelope affects the filter. So in this case, we can basically, this is nice. They click to the off position so you know it's completely disabled. And then you give it a little bit and you'll see that the filter changes as you play a note. And you can hear the filter change when you let go of the key. And that gives you an idea of how you can control the filter based on where on the keyboard you are playing. Now notice this has pitch control inputs, and it also has pitch control inputs on the filter, which may seem a little bit misleading, but it basically changes, you can modulate the control voltage that the filter goes through when you're playing a note. So in this case, we do have the contour or envelope enabled, which is we hear the filter open up. The resonance increase when I play the note and decrease after I let go. But we can also modulate the filter with the LFOs. So we'll go back, select, put the balance on X only, go back to a triangle because that'll make it easier to hear, and By changing the frequency of the LFO, we change the filter, how it opens up and closes down. That's just the control voltage going into it. And then of course we can mix the two LFOs together again the same way we did for the pitch. And the two control voltages interact. We can set the frequencies for the modulator separately, but it also has a master slider that speeds them up. And that we can auto-trigger the contour generator. Right now it's basically triggered by the keyboard with this one up. But we can also trigger that from a low frequency oscillator. So let's use B this time with a square wave. And oh, you can actually select either Gen X or Gen Y, or LFO X or Y separately for this. You cannot set the depth. There's no depth to set because in this case it acts as a simple trigger. And now we can use the pitch control input. That's both LFOs affecting it. And to demonstrate that the filter is actually self-oscillating, I will turn off the oscillator mix section and push up the resonance on the filter. So you can theoretically play the filter. So if you turn off this triggering here, and of course turn off the modulation, we need to turn on the keyboard. So theoretically, if you properly tune the filter to a musical scale, which is really difficult to do, but you could create a third oscillator that plays along with the tone oscillators. So this is a monophonic instrument, which means under normal circumstances it'll only play, in this case, the highest note played on the keyboard. So if I play this, I can play whatever I want on lower keys, and it's not going to do anything. But if I play a higher key, it'll only play the highest key. Now, one feature they added to this was that you could make it into a duophonic instrument, which means it'll play two different notes at once. This is something that came from the ARP Odyssey, which was out by the time this was released, and I guess they liked that feature, and they added it to this. For that, you set it to low note keyboard control, and pretty useless nowadays when most keyboards have 64 or 128 note polyphony. But in these days, in the early 70s, it was an added bonus to be able to play not quasi in this case, you're actually playing duophonically. Of course, i.e. two different notes at the same time. There's another way to achieve this effect, and that is to tune the oscillators apart. You will get two different pitches sounding the same time, but you can't vary the interval between the pitches because the oscillators will always track whatever interval you've dialed in. And of course there's glissando or slide, which is one of the archetypal synthesizer effects. So instead of jumping from one note to the other immediately, and you can change the amount of time it takes to jump to the next note. On max, yes, there's a whole bunch of other things on here. And let me caution you, even though this is sold as an educational tool and you look at it and kind of half looks like a toy, so it should be real easy to use. It's not really true. You can, once you get to know it, you can get all sorts of cool sounds out of it. But if you get one of these buttons set wrong, it'll act really strange. And if you're into fixing these things, you've got a screwdriver in hand, tearing the thing apart, wondering why it isn't working. Before you do any of that, check your switch setups. I've been in a couple of situations where it just acted, one of the oscillators just went off on its own, and I thought I'd lost the oscillator, but then I found out that I was modulating the oscillator, or what I did just before filming this video, what I didn't realize was I had the ring modulator turned in slightly. So in a ring modulator, you're basically taking two signals and outputting the sum and difference of them. And in this case, it's not too bad, but if we turn off the actual oscillator and then change the frequencies, see, now it's doing it to me because for some reason I'm not hearing oscillator A. Well, my mistake was that I had set one of the inputs to the ring modulator to be the XY LFOs. And that's why you were getting the rhythmic stuff, because the frequencies weren't that far apart, the frequencies. However, if we use another input, which is, we can use oscillator B as the main input, which is indicated by this line. Sorry, this gets a bit confused. Oh, over here, it ends up here, and that gets mixed with tone oscillator A. So that's what the sum and difference, what the sum and the sum and difference of the two frequencies sound like when you're not hearing the bass frequency, the bass, the originating frequencies, but oscillators sound like. Here's what the ring mod sounds like. And then you can mix it. When you have both oscillators almost at an equal frequency, obviously your ring modulator doesn't produce too much of an effect because the sum and difference is very close to the actual notes going in. But once you start messing around with the frequency, here we are about an octave. One oscillator is about an octave below the other oscillator. That's why the ring mod effects, again, become somewhat musical. But if you are an odd number of, not an octave off, that's pretty much it. The only other thing remaining is, let's see, there's an external input, so you can plug an external instrument over here and have it processed by the filter and the contour generator. It's also got these direct output mixers, which just give you the raw oscillator A. I mean, we're turning this mixer off, and this is not affected by keyboard. This just drones. And that's the ring modulator without any control. And I think that should give you a pretty good idea of what this thing is capable of. There's a lot more things you can do, the way you can route the LFOs around, and which really gives it a lot of depth, and maybe even teaches you some good sound principles. Well, we could go on ad infinitum, ad nauseum, but I think this gives you a pretty good idea of what this is capable of. Keep in mind, this is a purely analog synthesizer. There's nothing digital in the sound path in here. Closest we come to digital are on-off switches. Analog synthesizers, pretty much everything musical you bought before, let's say, the mid-'80s or early 80s was analog. Then they came out with digital instruments, and people started throwing these things away wholesale. I mean, they were, in those days I've looked around, and I was given a few of these instruments by studio owners who just said, just get it out of here. They didn't want it anymore. Everybody wanted a Yamaha DX7. Now, about 10 years or so ago, analog got rediscovered because people think that analog sounds better than digital. I won't get into that discussion, but you know, these instruments have risen in value, and you can buy a lot of new instruments that are advertised as purely analog. And of course, modular synthesizers now are all of the rage. You can buy them from many manufacturers, and really the only difference is this is kind of like an analog synthesizer, except that you don't use patch cords to connect anything together. These white lines represent patch cords that are permanently wired or normaled to whatever they show. On a modular synthesizer is you basically buy modules like this or this or this, and you put them in a case, and they got jacks on them, and you wire things together the way you want them to, and you can pretty much make it do whatever you want. The downside of it is you can't really save patches like on this one. If I come up with a really fantastic patch, the only way for me to save it is to shoot a picture of it, and hopefully be able to identify from that picture or video later on what everything was set to, and that's how you would recall a sound that you made previously. But what else can I say? They're a lot of fun, but they're really good studio instruments, but when you go live and you need to change sounds quickly, they do become somewhat burdensome. Thanks for joining me. I hope you liked this brief journey into analog synthesis. Well, it was supposed to be a repair only, but to recap, the only thing wrong with it was a couple of corroded pins on the main connector inside, and it came right back to life. We cleaned up here and there, put new caps in it, which did it a lot of good in stabilizing pitch generation, and with a lot of time left over. I mean, I started the second episode thinking there was going to be other things that don't work, but as it turns out, everything pretty much works in here. So took you on a brief journey of analog sound generation. So make sure you subscribe, and I guess I should also mention click the notify button, because otherwise the subscription, it's like subscribing to a magazine and not giving them your address. A paper magazine, that is. But yeah, subscribe, thumbs up if you learned anything new or just plainly enjoyed what I did here, and we'll see you next time around. Bye.